Hello Year 10. In this video I'm going to teach you how to use the cosine rule. First of all, I'm going to teach you how to use it to find a length in a non-right angled triangle, and then in the following video I'll show you how to find an angle in a non-right angled triangle. Just to get started, there are two questions here to do with the sine rule, which you learned last lesson. So what I'd like you to do is just to quickly have a go at these, the green one being the easier question and the red one being a slightly harder question. Okay, so pause the video now and have a go at these two questions, please. Okay, so first of all, if we have a look at the green question, we're looking for this angle here, which is labelled as B, and we can see we have the side opposite this, which is 3.6 centimetres. And then if we have a look, what we also have another angle, which is 100 degrees, and then opposite that a side of 5.1 centimetres. So we can set up the equation like this, 3.6 over sine of B is equal to 5.1 over sine of 100. Now all we've got to do is figure out what the value of B is here. So I can multiply both sides by sine B and by sine 100. So that will give me 3.6 times by sine of 100 is equal to 5.1 times by sine of B. So effectively I've just cross multiplied there. We want the B on its own, so we need to divide by the 5.1 here. So if we divide both sides by 5.1, we'll have 3.6 times by sine 100 divided by 5.1 is equal to sine of B. And then we just want the B on its own, we don't want sine of B. So we're going to use arcsine or inverse sine. So we can say inverse sine of all of this side divided by 5.1 is equal to B. And if you type that into your calculator, you will get that B is equal to 44.03984, which goes on and on and on. So if we were to round that to two decimal places, we have, here's our decimal point, 1, 2. It's a 9 after a 3, so that means it's going to round up. So B is equal to 44.04 degrees to two decimal places. Okay, so the red question was a little bit more difficult. So we had our triangle here, ABC. It gave us all of the information just here, and this time it wanted the area of the triangle. So that means that I'm going to be using the area formula, which is half AB sine C. So remember, with the area formula, the angle must be enclosed by the two sides. So I need an angle and the two sides that are adjacent to the angle. So at the moment, I only have one side, so I need to find another side somehow. So you can see that this side is opposite this angle, and then also we have this angle opposite this side, so it's possible for me to find this side here using the sine rule. So I'm just going to do that first of all. So this side is opposite the vertex B, so I'm going to label that side B. So if I set up my equation, it will be B over sine of 49 is equal to 8.7 over sine of 64. So B is being divided by sine of 49 here, so I must times both sides by sine of 49, and I have B is equal to 8.7 times by sine 49 all over sine of 64. If I type that into my calculator, then I will get that B is equal to 7.305314 and on and on and on. We want our final answer to 3 significant figures, so I'm just going to round this to 4 significant figures, so 1, 2, 3, 4. So that means B is going to be 7.305 centimetres. Now, if I want to, so in fact I'll label that just here, so 7.305. So if I want to use this area formula, like I said, I'll need two sides that are enclosing an angle. So I have a side here and a side here. So I need to find out what the angle is here. So I can just use angles in a triangle, add up to 180 degrees to find this. So I can say 64, add 49, which is equal to 113 degrees. Take that away from 180 degrees. And I get that that angle there is 67 degrees. Now I can use the formula that I wanted to before. So I'm going to use the area formula. So A equals half AB sine C. So we have half times by A, which I'll call 8.7 centimeters, B, which is 7.305, and then sine C, which C is 67 degrees. So if I type that into my calculator, I will get that the area is 29.25066526, or as we want it to three significant figures, that's going to be 1, 2, 3. It's a 5 after the 2 here, so that means it's going to be 29.3 centimeters squared. And that's how we do that one. Okay, so this is a new learning that we have for today. So on this question here on the left, I'm looking for the length of AC, which is just going to be this side here. So this is different, and I know I can't use the sine rule, because if I write down the sine rule again, so A over sine A equals B over sine B, the sine rule involves two angles, so we can see that we have one angle here and one angle here. In this question though, I have three sides that I'm looking at, so 1, 2, and then we want this side here, and we just have one angle there, so I can't use the sine rule for this. Similarly, on the right hand side, we're looking for an angle here, A, and I can't use the sine rule as there's only one angle, and I've been given three separate sides here. So I can't use the sine rule here, and obviously I can't use Pythagoras or sine, cosine and tangent in a right angle triangle, because neither of these triangles are right angled triangles. So this is what we need the cosine rule for. So the cosine rule is a formula involving one angle and three sides. So if we have a look at, again, a general non-right angled triangle, you can see that we have three sides, which we can label A, B, and C, and then the three vertices opposite them, which are labelled A, B, and C also. So if we have a look in the formula itself, it's involving three sides, so side A, which is a side that we're looking for here, and then the other sides there, which are B and C, which also appear here and here, and then we're looking at the angle which is opposite the side we're looking for, which again is angle A here, so that would be just there. So if we look over to the right hand side of the screen where we have this question here, you can see that I'm looking for a side, I have the other two sides, and I have the angle opposite that side. So this will require the cosine rule. The way that I remember using the cosine rule, if I need the cosine rule, is if it's a non-right angled triangle and somehow all three sides are involved. So this side and this side we're given, and this side is the side that we're looking for. We'll also need the angle as well, which is opposite this side here. So with that in mind, what I would like you guys to do is to have a look at all of these questions here and tell me which ones you would be able to solve, so find the missing letter or the missing side or the missing angle using the cosine rule. Remember, the cosine rule involves three sides and one angle. Okay, so pause the video now and have a go at that. Okay, so I'll just quickly go through these now. So the first question here, it involved only two sides, so 41 and 28 here, and two angles, so that one is not the cosine rule. You should have actually used the sine rule for that one. Similarly, on the second one, you had a side and the angle opposite, a side and the angle opposite, and you were looking for one of those angles, so that would have been the sine rule as well. On the third question, you had three sides involved, and you were looking for an angle, so you could have used a cosine rule for that one, so that one was the cosine rule. On the next one, you had two sides given to you, and it was asking for the other side, this x here, and you had the angle opposite that, so this one was also the cosine rule. On to question 5, well, this one, there were only two sides involved, and there were two angles, so that was the sine rule. Question 6 was just Pythagoras' theorem. It was a right angled triangle, and you were just looking for a side in that. There were no other angles apart from the right angle involved. And then the last question, you had three sides involved and one angle opposite one of those sides, so therefore that one was a cosine rule as well. So well done if you have those correct. So let's just do a quick example of how to do that then. So on this first question here, you can see that we have 3 sides involved. This side here, and then this side, and this side there as well. So we're looking for this side here, and we have the angle which is opposite that side there, just over here, which is 27 degrees. So if I write down the cosine rule, which is a squared is equal to b squared plus c squared minus 2bc cos a, you can see that I have a here, which is what I'm looking for, and then b and c are the 2 sides opposite that. So we have b can be 11.2, c can be 7.5 centimeters, which are again later here, and then cos of a, which is the angle opposite that side that I'm looking for, so a here is 27 degrees. So I'm just going to put all of that into the formula. So a squared equals 7.5 squared plus 11.2 squared minus 2 times b times c, so times 7.5 times by 11.2 times by cos of a, so cos of 27 degrees. I'll type all of that into the calculator, and I will get that a squared is equal to 32.00903994. Obviously this is a squared, not a, so I have to square root that to get a is equal to 5.656934, and on and on and on. We want 3 significant figures, so that's 1, 2, 3 significant figures there. It's a 6 after the 5, so that means it's going to round up. So a is equal to 5.66 centimeters to 3 significant figures. Okay, so let's have a go at the one on the right hand side as well. So again, we're still using the cosine rule, so I'll do this one a little bit quicker. So a is just over here, and then we can use this as b and this as c, and obviously this is opposite a, so this is angle a here. So I'll substitute everything into the cosine rule. So a squared equals b squared, so 3.7 squared, plus c squared, 4.9 squared, minus 2bc, so 2 times 3.7 times by 4.9 times by cos of a, which is 65 degrees. Again, I can type this into my calculator, and I'll get that a squared is equal to 22.37586183, and on and on and on. Again, that's a squared, not a, so I need to square root my answer, and that will give me that a is equal to 4.7303130079. It doesn't tell me how to round this question, so I'll just round it to 2 decimal places. So that would be a is equal to 4.73. And that's all we need to do. Okay, so now it's your turn. So what I would like you to do is to pause the video, have a go at finding these missing sides on each of the triangles, and then in a moment unpause the video and just check and see if you've got the answers correct. So pause the video now, please. Okay, so these are the answers to those missing sides. I will go through these in another video just a little bit more clearly. And the next lesson is going to be on how to find angles using the cosine rule. Thank you and have a good day, Year 10.